Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Who Are You by Jonesy, and here are the rules. Hello. We have irregular Sudoku rules. It's actually, I think, chaos construction rules. Yes. Where we need to fill the grid with the digits 1 through 9 so that each row, column, and region contains all digits once. But we don't have a designated 9-cell region. Because of that, it's not typical irregular Sudoku rules, it's actually just chaos construction rules. The 9 regions are orthogonally connected and form a 180-degree rotationally symmetric layout. So that means if we had a region like this here, you would have to have an equivalent here because it must be 180 degrees rotationally symmetric, right? And what does it mean to be orthogonally connected as a region? It means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So, for example, this is a valid orthogonally connected 9-cell region. This, however, is not, because to get from this cell to any other cell in that region, you either have to go through a corner or go outside of the region, which is not allowed. Same with this. This does not work either because, again, you'd have to go outside the region for these two cells or go through the corner that's here, which is not allowed. And remember, the regions will be 180 degrees rotationally symmetric. So that means if you rotate the grid 180 degrees, it should look the same. So that's why we know if this is essentially the region here in this upper left-hand corner, this must then be the region here around this lower right corner. Because if you rotate it 180 degrees, that would still stay, the regions would basically still have the same shape. Okay, so remember that and keep that in mind. We have cages of the same color have the same unknown total. So all the blue cages must add up to the same total, and all the red cages must add up to the same total, which we do not know. Okay? Interesting. Within a cage, digits of the same parity belong to the same region. So if these were the same parity, they would belong to the same region. And digits of opposite parity cannot belong to the same region. So we know these digits are opposite parity because they're consecutive, right? So you can't have an odd consecutive with another odd or even consecutive with another even. So these must be opposite parities. So we know these are in different regions then. And these must be, these could be the same or these could be different. Okay. A white dot marks consecutive digits. So these are white Kropke dots. So for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And a black dot marks a 2-to-1 ratio. So for example, if this were, say, a 2, this would have to be a 1 or 4 to maintain the 1-to-2 ratio between them. And have fun. We will try. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the first thing that pops out to me, since all the red cells sum up to the same sum, they are guaranteed to be one odd and one even, right? Because they are always consecutive. So for all the red cells, you will always have a especially since it's two cells, you will always have a border between them, between the two cells, because they're different parities. And we can do that 180 degrees rotationally. So that means 1, 2, 3 this way is 1, 2, 3 this way. So these are different regions. 1, 2 this way is the same as 1, 2 that way. So those are different regions. These have to be different regions here, rotationally symmetric. Here is equivalent to here. That means this is equivalent to here. This is rotationally symmetric that way. So, because these are in a 1 to 2 ratio, that means one of these digits must be odd. The only odd ones you can have are 1 with 2 and 3 with 6. But 1 and 2 would mean that these red digit sums must add up to 3, which is impossible. So this has to be 3 and 6 then, which makes this a 4. This adds up to 9, which means all the red cells add up to 9. So this has to be 4 and 5 to be consecutive. This is 3 and 6. This is 4 and 5, which is consecutive with 3 or 6 here. These are consecutive. This cannot be 4 or 5. So we could have 1, 2, this can be only 1 through 8 in the red cells. 1 through 8, 1 through 8. This cannot be a 3-6 pair here because a 3-6... Oh, wait. Hold up. So these are all correct. I messed up a boundary. This boundary is not correct. This corresponds to this boundary here. This boundary corresponds to that boundary there. This cannot be 3 and 6 because that would eliminate all possibilities for this cell here. This could be 1, 2, 3, 6, 7, 8, 9, which is consecutive with that one. We have in row 2 3 sets of digits which are in a 1 to 2 ratio. That means it's either 1, 2, 3, 4, 6, or 8 in those cells, which means the remaining cells in this row are 5, 7, and 9. So this is 5, 7, and 9. This can't be 9 because this adds up to 9 with this cell. This 4, 5 pair eliminates 4 and 5 here, so this is 7 and 2. That eliminates 7 in the rest of row 2. 2 has to be with 1 because 4 has to be with 8 in this row. So this is 1 here. So these are the same parity, so therefore they're the same region. 5 and 9 are consecutive with 4, 6, or 8. This has to be 3, 4, 6, and 8 as a pair 1 to 2 ratio in row 2. So let's draw the grid around the entire, let's draw boundaries around the entire grid. So this is a boundary. This is a same boundary. So light has to go here. Blue has to go here. This is a separate region. So this is a separate region. This will be green. And we'll mark this as orange. This will mark as pink. It has to go this way. And it has to be 180 degrees rotationally symmetrical. So therefore both of these are part of pink. 2 and 7. We don't know which one's which here. This cannot be 1 and 8. It cannot be a 3, 6 pair. It's either 2, 7, or 4, 5 to add up to 9. This cannot be 4, so therefore this can't be 8 here. If this is 1, so what are the possibilities here? If this is 1, this would be 2. If this is 2, this is 1 or 3. If this is 3, this is 2 or 4. If this is 6, this is 5 or 7. So it could be all of them also still. Okay. Well, never mind that. These two are boundaries. These are consecutive. Okay. This is a separate... Oh, these are separate regions. So then this must be a separate region here, which means this is a separate region here. This must go this... we don't know. So this is medium. Light has to go this way. Blue has to go this way, which means green has to go here. Orange has to go here. These are boundaries. Boundary, boundary, boundary. Hmm. If the blue sum is even, that means all 2-cell blue cells are basically the same, have to be the same region. That's interesting. Oh, they have to be. Because these are the same region and these are the same region. So the blue cells must sum up to an even region. So that means green has to go down here because so since these, well, this could be a different region than this. We don't know. But for every 2-cell blue cell, it has to add up to an even sum. So they must be the same parity no matter what. So green has to go here. Orange has to go here. Orange must go this way. And green must go this way. So because of that, light has to go this way. Blue has to go this way. So we have a border here, a border here, a border here, and a border here. That means gray has to, medium has to go this way. Yellow has to go this way. So we have a border here and a border here. Medium has to go this way because of the 2-cell blue cells must be the same sum. Same with yellow, actually. Pink has to go this way, which means pink has to go this way. Since pink is this way, this must go pink that way, which means that pink has to go that way. Blue has to go this way then. So blue must go here. It's blocked by this, so blue has to go here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is all blue. This is all light. And that's the border for blue. Yellow has to continue this way. This has to be some sort of red. Red has to, because it's not the same region because of this part. So red has to continue this way. Yellow has to continue that way. Red has to continue that way. This is all dark. So all dark here. Medium gray goes here, here. And it still must continue out this way. This is yellow, which means it continues out that way. This is all medium. Which means this is medium too. Which means dark has to go here, and then dark has to go at least these two. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So red is all this way too. We have 1, 2, 3, 4, 5, 6, 7, 8. If we tried to include this, it would have to be with both. So then it has to just be here. So that's done there. This is done that way. So we have the boundaries here. This is yellow. This is medium. This is dark. We have light this way. Okay, so pink cannot go here, because if pink goes to here, it must be in all of those, and then there would have to be there symmetric. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cells. So pink has to go this way. And pink must go this way to be symmetric. Orange has to be the remaining cells. So orange is here and green is here. So these are the boundaries for the remaining regions. Okay. These are both even. Sorry, these are both odd, so this must be even here. So this is 2, 4, 6, 8, which is consecutive with 1, 3, 5, 7, 9. We don't know what the sum is. We know reds add up to 9, so that's fine. We have a guaranteed even here. This is even, and this is even. That's 3 evens in row 1, so this cannot be even. This must be 2 odds here, right? If it's 2 evens, that would mean 5 evens in row 1, which is not allowed. So these both must be odd. 1, 3, 5, 7, 9. Okay. We have a 3, 4, 5, 6 quadruplet in the blue region, which eliminates 3, 4, 5, 6 in the rest of the region. This can't be 4, 5. It's 2 or 7. That eliminates 2 and 7 in the rest of the column. This can't be 2. This is 4, 6, or 8, which means this can't be 1. Remaining digits in the blue region, then, are 1, 2, 7, 8, 9. This can't be 1, 2, or 7, so this is 8 or 9. This can't be 2 here. These must be the same. These have to be the same parity. So, and 8, if 8 were here, this could not be an even parity, because we don't have 4 or 6 available, and we don't have 2 available. So this cannot be even parity. This must be 9. Which eliminates 9 in the rest of the region. 2 then has to be one of these 2 cells. And this must be 1 or 7 to add up to an even digit, if they're their same parity. If you have 7 and 9, there's no way that any of these, all of these blue cages can add up to 7 and 9. So this must be 1 and 9 here. So this is 1 and 9, which eliminates 1 in the rest of the blue region. So that means blue must add up to 10. So this cannot be 1 and 9 here. This must be 1 and 5, which forces this to be 9. 5 is consecutive with 4, 6. But 1, 5, and 4 add up to 10. So this is 4, this is 6. 4 is consecutive with 3 or 5 here. There's no more 4 or 6 in the rest of the row. So this cannot be 3, 6, or 4, 5, adding up to 9. This is not 6 here. So these add up to 10. So this must add up to 10. There's no 5 here. This is either 1, 9, or 3, 7. So we're guaranteed a 1 or 7 here. We are guaranteed a 1 or 7 here. This is either 1, 8 or 2, 7 here, so it's a 1 or 7 here, which eliminates 1 and 7 in the rest of the row. This can't be 1 or 7. So this can't be 4 or 6, no 1 or 7, 2, 3, 4, no 2, 3, 5, 8, and 9 are possibilities. And this can't be 5 because of the 4, 5 pair in the column. So where is the 5 in row 1? Can't be here because of the 4, 5 pair in the column. Can't be here because of 4, 5 pair in the column. This can't be 5 and 5 to add up to 10 because that's a repeat in the row. This can't be 4 and 5 adding up to 8. And this can't, again. So therefore 5 has to be here. These are 2 digits adding up to 10. No 1, 9 or 2, 8. So it's 3, 7 or 4, 6. 3, 7, 4, 6, adding up to 10. If these were 2 evens and this were odd, it would not add up to an even number. It would add up to an odd number, which 10 is not. So this must be even, so it's 2, 4, 6, 8, and these must be odd. So 1, 3, 5, 7 adding up. So this is 2, 4, 6, 8 to be consecutive with 1, 3, 5, 7. This cannot be 1 and this can't be 1 and 8 because of 1 in the row. This can't be 1, 9. These can't be 1, 9. So we have 2, 3, 4, 6, 7, 8. 2, 3, 4, 6, 7, 8. 2, 3, 4, 6, 7, 8. 2, 3, 4, 6, 7, 8. In these cages that are 2 cells. Well, this can't be 4, 5. Where is the 5 in row 7? Can't be here because of 4, 5 pair. This must add up to 10 with another digit. Same with this, same with this. This is not 4 or 5 because of 4, 5 pair in the column. So 5 has to be one of these 2 cells, which forces this to be a 4, 5 pair, which eliminates 4 and 5 in the rest of the row. So this can't be 4, which means this can't be 6. No 4, no 6. No 4, no 6. We have 2, 3, 6, 7, 8 here, but this can't be 7 because of 7 in the column. This could be 1, 2, 8, 9 if this is 1, 2 here and this is 8, 9. Or 3 and 7 or 4 and 6 this way. We have 4, 5, 6, 7 in the dark region. So this cannot be 7, which means this can't be 2 here. So we are guaranteed in row 1, 2 has to be one of these 3 cells, which means that 2 cannot be in the rest of the dark region here. So this is 1, 3, 8, or 9 here. This cannot be 4 and 6 because of 4 of the 6 in the column. So to add up to 10 here, it's 2 and 8, 4 and 6, or 7 with 3. Here, it's 3 and 7, or 4 and 6. Okay, this one eliminates 1 in the rest of the region. So this can't be 1, which means this can't be 8. Okay. Let's see. These digits are consecutive. We have 3 pairs of digits adding up to 10. So this is 10, 20, 30. So these 3 must add up to 45 minus 30, which is 15. So, and you have a 5 guaranteed, so it has to be 5 with 4 and 6. So this is 5. We have a 4, 6 pair remaining. to add up to 15. This can't be 4 and 6 then, so this must be 3 and 7, because if it's 4 and 6, it would eliminate all possibilities for this cell. 3 is only in a 1 to 2 ratio with 6, so that's 3 and 6. 7 in the medium region eliminates 7 in the rest of the medium region, so this is 8. 8 and 1 add up to 9. 1 is only consecutive with 2. So therefore, this cannot be a 1-9 pair. It's a 3-7 pair, which eliminates 3 and 7 in the rest of the region. This can't be 4-6 because of the 4-6 pair in the region. So this is 8 and 2. 8 is in a 1 to 2 ratio with 4 here. So we have 1-9 remaining in the light region. This 6 eliminates 6 here. So this is 3, which is consecutive with 4, which is consecutive with 5. 4 eliminates 4 in the rest of the blue region. That's 5. This can't be 3. That's 6, which makes this 3. This can no longer be 3-7, adding up to 10 in the yellow region. So this is 2-8 as a pair, which eliminates 2-8 in the rest of the column. So this can't be 2 or 8. It's 7, which makes this not 7. So it's 2 and 7 here. This 7 in the blue region eliminates 7 here. So this is 8, which eliminates 8 in the rest of the row. So this is 2. That's 8. No more 8 here. This 5 eliminates 5 here, so this is 4. This can't be 2, 3, or 8. It has to be 9. No more 1 and 9 remaining in the dark region. We have only 4 remaining in the medium gray region. So this is 4, which eliminates 4 here. So that's 6, which makes this 4 here. This cannot be 6 or 8 here. It couldn't have been 8 anyways. No 2, 8. No 4, 6 here. This is a 3, 7 pair in the green region, which eliminates 3 and 7 in the rest of the green region. This is 1 and 5, which adds up to 6. 6 plus 4 adds up to 10, which is what the blue cage must add up to. This cannot be 3, 7 or 4, 6, so this must be a 2, 8 pair. 2 cannot be here because of 2 in the row, so this is 8 and 2. 3 eliminates 3 here, so it's 7 and 3. That means this cannot be 3 and 7, 2, 8, or 4, 6. This has to be 1, 9 to add up to 10. 1 eliminates 1 here, so it's 5 and 1. 5 is only consecutive with 6 left. 5 eliminates 5 here, so it's 4 and 5. This can't be 4 and 6 in column 8. Is a 3, 7 pair. 7 eliminates 7 here, so this is 3 and 7, which eliminates 3 in... This can't be 2 or 3. This is 6. That leaves a 2 in column 9, which leaves 5 and 8 remaining in the orange region. 5 can't be here because of 5 in the row, so this is 8. This is 5. 8 eliminates 8 here, so it's 3 and 8. That leaves in column 7, the remaining digit is a 6. We're missing in the yellow region. Well, this adds up to 10. There's no 2, 8, no 3, 7, no 4, 6. It must be 1 and 9. 1 can't be here because of 1 in the column. So this is 9, which makes that 1. We're missing 5 and 7 remaining in the yellow region. This can't be 5 because of 5 in the column. So this is 7 and 5 here. That leaves a 3 remaining in row 8. So this is 3. 3 eliminates 3 here, so it's 7 and 3 in column 1. This can't be 3, 7, 4, 6. Cannot be 1, 9, adding up to 10 because of the 1 in the green region. So this must be 2 and 8. And 2 can't be here, so this must be 8 and 2 here. This cannot be 2, 8, 4, 7, or 3, 6 because of the digits in the pink region. So this must be 1, 9. 1 can't be here because of 1 in the row. So this is 9, that's 1. Which eliminates 1 here, so that's 9 and 1. That leaves this digit as 6 and this digit as a 3 in the pink region. That leaves this as 2 in column 3. In column 4, missing a 9. In column 5, we're missing an 8. In column 6, we're missing a 4, which is in a 1 to 2 ratio. That works. In row 4, we're missing a 6. In row 3, we're missing a 9. That leaves this as 1 and this as a 7. Thanks for playing. Yeah, thank you for this. This was actually, it's very rare you get a chaos construction rule set, which I would consider easy, but I think I would consider this as easy. The rules make a lot of sense. It flows very well from one to the next. Since you have a 180-degree symmetrical rule, that really limits where things can be, right? So yeah, it's yeah, very well done. It's not easy to make an easy level chaos construction rule, but I think this might be just the one of the few that does do it very well. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.